Hello friends, welcome to Crackgate CSE, and in this series of database, our today's topic is normal form. So in the previous video we have discussed 1NF and 2NF, that is first normal form and second normal form. And in this video I am going to discuss third normal form and BCNF, that is Boyce Codd Normal Form. And after this particular video I will be giving you around 5 to 6 practice questions so that you can have a complete grip on this particular topic. So without wasting time, let's start this. So the third normal form. So if every non-trivial functional dependency which is x derives y with x as a super key or y as a prime attribute. So what is the meaning of this? That means the this x should be a super key. Either the left hand side should be a super key or the right hand side should be a prime attribute. So if these two conditions has been satisfied, then it is said to be in 3NF. Second is, there does not has to be any transitive dependency. That means if there is no transitive dependency, then the relation is said to be in 3NF. So what is the transitive dependency? Transitive dependency, when a non-prime attribute transitively determined by candidate key or a super key is not allowed in 3NF. So what is the meaning? That if x is a candidate key or a super key and it is deriving some element y, and if that y attribute is deriving some z which is a non-prime attribute, so this type of condition, this type of scenario is not allowed in 3NF. While if there is a x which is a super key is deriving y and y is further deriving an attribute which is a prime attribute, that means if any non-prime attributes it derived by x, then it is not in 3NF. If the non-prime attribute is derived from x, then it is not in 3NF. But if the prime attribute is derived from the candidate key, then it is said to be in 3NF. Let's try to understand this with the help of a small example. So this is an example, a relation R with these 5 attributes. So first of all, what we need to do is we need to find the candidate key for this particular relation. So with this functional dependency, we can know that AB is deriving C. That means AB is deriving C, BC is deriving A, B and C is deriving A and C is deriving B. That means A and C is deriving B. So you can see that D and E are not in the functional dependency set. That means the D and E should be in the candidate key. Now if you find out that finding A, B, D, E will be getting all the attributes, that is from AB we are getting AB itself, then C, and we are already having DE as a attribute. So this way you can find out that there are 3 candidate keys like ABDE and BCDE and ACDE, right? So these are the 3 candidate key whose closure will give you the same value, that means all the element in the relation every time. So we have find out the 3 candidate key. Now we have to find out whether this particular functional dependencies are satisfying the third normal form or not. So how to find out? Go with the first functional dependency. So I told you either this x should be a super key or this y should be a prime attribute. So what are the prime attributes? First of all, A, B, C, D, E, all are the prime attributes. So here you can see that AB is deriving C, so this C is a prime attribute. Right hand side is a prime attribute. Here again right hand side is a prime attribute. Here again right hand side is a prime attribute. That means all of these 3 functional dependencies are satisfying the condition of 3NF. So this relation is in 3NF. One more thing, if all the elements of a relation are prime attribute, if all the elements of a relation are prime attribute, then it is said to be in 3NF, because there are no chances that any particular candidate key is deriving the non-prime attributes. So this kind of scenario will always says that the particular relation is in 3NF. Now let's go with the BCNF, that is Boyce Codd Normal Form. So in BCNF, the relation is said to be in BCNF if we talk about this particular functional dependency, then X should be a candidate key. If X is a candidate key, then it is a BCNF. That means if left hand side is a candidate key, then the relation is in BCNF, otherwise it is not in BCNF. So unlike 3NF, in 3NF we have to check for left hand side. If it is a super key, then it's okay, and if it is not a super key, then we have to check the right hand side. But in BCNF we only need to check the left hand side, and if the left hand side is a super key or a candidate key, then the relation is in BCNF. How? Let's see. There is a relation with three attributes A, B, C. So find out the candidate key first. So what are the candidate key? A, B, B, C and AC. These three are the candidate key. Now you can check each functional dependency. Left hand side is a key. Yes. Left hand side is a key. Yes. Left hand side is a key. Yes. That means the relation is in BCNF. So this way you can find out whether the relation is in BCNF or in 3NF. So if it is in BCNF, it will also satisfy the condition of 3NF, right? So there is a particular image. Let me tell you that if a particular, so this is the image. If it is 4NF, then it is BCNF also. If it is BCNF, that means it is 3NF also. If it is 3NF, then it is 2NF also. And we know that if it is 2NF, it is 1NF, because 1NF is the default one in RDBMS. So there are some questions which can be on this particular topic. One more thing is that if we try to find out the design goals. So first of all, what are the design goals? Design goals of normalization. So there are three design goals of normalization. First is lossless joint decomposition. Second is dependency preserving decomposition, and third one is redundancy. That has to be 0%. That means no redundancy. So these are the three design goals of normalization. So on the basis of these three design goals in normalization, the 4NF may or may not be lossless join. It may or may not be dependency preserving decomposition, but it is always having 0% redundancy. So I will let you know all these things in the next video, where I will be discussing the design goals of normalization and few small facts on basis of which there can be gate questions. So I will be discussing these design goals along with this particular table. I will be giving you a table of all these things, and we will be also discussing some important questions on finding out the normal form. So if you find this video useful, like it, share it, subscribe my channel if you are new, comment, because your appreciation really matters to me. Your appreciations are kind of boosters that allows me to work more hard for you. And if you are not connected with me on my Facebook page, my group and my personal profile, I will be giving you the link in the description so that you can follow and join the group. So thank you very much for your support. Keep supporting, keep learning. Have a great day.